tissue system. Every plant body is made up of three types of tissues, namely epidermal, fundamental and vascular. So for epidermal tissue system, fundamental tissue system and a vascular tissue system. The TS stands for tissue system. See, this classification of tissues was made by Sachs in the year 1875. See, what is the epidermal tissue system? So, epidermal tissue system is the outermost covering of the plant body. This is the epidermal tissue system is the outermost covering of plant body. It includes epidermis, stomata, cuticle and epidermal outgrowths. So what is epidermis? Epidermis is a single layer of cells compactly arranged without any intercellular spaces. In the case of roots, the epidermal cell does not have any gaps, but in the case of stem, the continuity of the epidermis is interrupted by the presence of minute pores called stomata. And in most cases, especially in stem and leaf, epidermis is covered by cuticle. It is a waxy substance that covers the epidermis. What is the function of epidermis? It gives protection to the internal tissues that lie inside. And stomata are minute pores which are covered by two bean-shaped cells. And in the case of monocots, these bean-shaped cells are found in dumbbell shape. Bean-shaped cells are found in dumbbell shape. And they are covered by two subsidiary cells. These are called subsidiary cells. And these stomata, what is the function of stomata? Stomata is useful for gaseous exchange, transpiration, and also the intake of things, especially sometimes water also. And cuticle, as I said, this protects the epidermis and epidermal outgrowths. In some cases, there are unicellular or multicellular outgrowths present on the epidermis. These multicellular appendages may be branched or unbranched, and these are called trichomes. In the case of roots, the epidermal outgrowths are produced as an extension of epidermis, and these are called root hairs. In the case of stem, these are called trichomes. What is the function of root hairs? Root hairs involved in the absorption of water and minerals from the soil, and it is connected to the roots. And what is the function of trichomes? Trichomes are useful in the dispersal of seeds and fruits. So this, in short, we can say like that. And this is about the epidermal outgrowths. Then fundamental tissue. Fundamental tissue. See, fundamental tissues are of two types. One is the extrastellar and next is intrastellar. Extrastellar. What are extrastellar ground tissue? Extrastellar ground tissue are hypodermis, cortex and endodermis. And extra means outside. Intrastellar outgrowths. Intrastellar ground tissue. They are medopith, pericycle, pith and medullary race. Medullary race. See, these are all ground tissue. What are ground tissue? Fundamental tissue is also always called ground tissue. See, this is the actual tissue that positions all the vascular tissues inside. See, epidermal tissue gives protection. Fundamental tissue fills the gap inside, in which the vascular tissues are located. See, you know, hypodermis. This is few layers. It varies plant to plant. For example, if you take dicot stem like Helianthus, it extends for 3 to 4 layers and they are made up of collenchyma. If you take in the case of maize, it is made up of sclerenchyma cells. So what is the function of hypodermis? Hypodermis is giving mechanical support. Then cortex. What lies next to hypodermis is cortex. It is made up of mostly parenchyma cells. In some cases, especially in Helianthus, it is made up of collenchyma next to hypodermis, collenchyma, chlorenchyma and parenchyma. Then endodermis is a single layer of barrel-shaped cells. And we will see about this in detail afterwards in the primary structures. And interstellar ground tissue comprises pericycle, pith and medullary race. Pericycle is the next layer that comes next to the endodermis. It is made up of a single layer of cells. Usually, it is not very prominent in stem. It is very clearly seen in roots. This is the layer from which roots originate. That is why the branches in roots are called endogenous in origin. But in the case of stem, the branches are produced from the external tissue and so they are called exogenous in origin. This is one of the very important questions. And medullary race and pith are nothing but same. Pith fills the entire inner surface and there are certain cells which radiate from the center towards the periphery. They are called medullary race. So this is some sort of the fundamental tissues. Then third is the vascular tissue. Vascular tissues. What is a vascular tissue? See, first, vascular tissues are the tissues which are involving in conduction of water and minerals. Conduction. These are conducting tissues. We know in plants the water is absorbed by the root hairs, that is transported to the rhizodermis, that is the outermost layer, and then to the cortex, then to the xylem and phloem. And especially to xylem. In the conducting tissue, there are xylem and phloem. We know xylem is the water conducting tissue, phloem is the food conducting tissue. So vascular tissue comprises xylem and phloem. But the vascular tissue, based on the mode of arrangement of xylem and phloem, vascular tissues are divided into three types. One is radial vascular bundles, then conjoint vascular bundles, then concentric vascular bundles. What are radial vascular bundles? So radial vascular bundles are generally found in roots. See, if you consider this as a ground plane of root, if you take a dicot root, xylem is at the center and phloem is found in patches like this. This is xylem, this is phloem. This is protoxylem, this is metaxylem. You see the position of phloem and xylem. Xylem and phloem, the radial vascular bundle, xylem and phloem are arranged in different radii. You consider the protoxylem, not the metaxylem. Xylem and phloem are arranged in different radii. Such vascular bundles are called radial vascular bundle. We can take any dicots and monocot roots. Dicot and monocot roots. Now we can draw the monocot root also, but this is enough. Then conjoint vascular bundle. What is a conjoint vascular bundle? The conjoint vascular bundle, there are two types, collateral and bicollateral. Collateral and bicollateral. What is collateral? If you take a dicot or monocot stem, we will take a dicot stem, and I do not draw all details. I take only the position of the structure of the vascular bundles. You see, this is start sheath. Inside this, the vascular bundles are arranged in the form of a ring. So you would have heard about the nature of arrangement of vascular bundle in a dicot stem. This condition is called U-steel. What do you call that? U-steel. What is a U-steel? What is a U-steel? U-steel is one where the vascular bundles are arranged in a ring. Around pith. This is pith. That condition is called U-steel. But actually this is not our interest now. This is an additional point. And what is a collateral vascular bundle? The collateral vascular bundle, you see, this is the periphery, this is the center. This is center, this is periphery. Here phloem and here is xylem. See the position of xylem and phloem. Phloem and xylem are lying in the same radius. This is called collateral. This is called collateral. Conjoint collateral. This is conjoint. When xylem and phloem are lying in the same radius, that is called conjoint. When phloem towards periphery and xylem towards center, that is called collateral. So this is conjoint collateral vascular bundle. This is found in the case of sunflower. This is found in the case of sunflower. I think you would have understood what is conjoint collateral. And what is bicollateral? This is the case of helianthus or sunflower. Bicollateral. You see this. Let me draw the single vascular bundle alone. Bicollateral vascular bundle. This is cambium. Here is a xylem inside. This is phloem. You see xylem, phloem. So xylem is lying at the center and at the center of the vascular bundle, and phloem is found on either side of the xylem. This is called bicollateral vascular bundle. This is called bicollateral vascular bundle. This is found in cucurbitaceae. You can see that in the book cucurbitaceae. And the next type is concentric vascular bundle. Concentric vascular bundle. What is a concentric vascular bundle? Concentric vascular bundle is one where either xylem is surrounded by phloem or phloem is surrounded by xylem. This is called concentric. See, concentric, and in the concentric, as I said, there are two types. You see one example. In detail, this is xylem. If you consider this as xylem and this as phloem. Xylem and phloem. This is called amphicribral vascular bundle. Amphicribral vascular bundle. Amphicribral vascular bundle is one where xylem is completely surrounded with phloem. The example is polypodium. And you can also see many examples for this in the text. And to the contrary, at the center phloem, and that is surrounded by xylem. This is phloem, this is xylem. This is called amphi-vessel. Amphi-vessel vascular bundle. Amphi-vessel vascular bundle. So this is found in Acorus. This is found in Acorus. So far we have seen that this is a basic pattern of arrangement of tissues. See, epidermal tissue system. See, according to Sachs 1875, there are three types of tissue system in the plant body: epidermal tissue system, fundamental tissue system, and vascular tissue system. We have seen a little in detail about the vascular tissue system, and these tissue systems are found in different pattern in different part of the plant body. So it varies, the arrangement of the tissues. Epidermal tissue, fundamental tissue and vascular tissues are arranged in different pattern in different plants and also different parts of the plant body. So we are going to see that in that. Here, what is a tissue system? There is a little definition for that according to Sachs. Group of tissues performing similar function in different parts of the plant body. So for example, epidermal tissue system, wherever it is, its function is one. Whether it is found in stem or found in root, in stem, it is found in stem, it gives protective function. Root, that gives protective function. In that way, group of tissues performing similar function irrespective of their plant body, irrespective of their position in the plant body is called a tissue system. So far we have seen three types of tissue system. And now we are going to see how these three types of tissue systems are distributed in different parts. Right, it's over. Now let's pass on to the next topic. Lectures, now we will give the roots.